Hello, guys. As I started on Friday, I guess I got back to streaming. We stopped on Friday on trapping rainwater problem. So today we'll be continuing from this one. Yeah, let me set up everything. So hopefully we are up and running, everything good. Yeah, checking the client. This part is good. So this part, not yet showing. I guess now it's showing. Okay, cool. Yeah, awesome. Now we are up. Yeah, let's get back into the mood of what was that problem, because I forgot a bit. It was on Friday, but we spent some time trying to figure out. Okay, so it's about trapping rainwater. We have an n, non-negative integers, representing an elevation map. So yeah, we have some bumps where the width of each bar is 1. We need to compute how much water we can trap after raining. So I think we started looking into our whiteboard, and we were trying to do a couple of scenarios, and the idea it's similar to the previous problem, where we have a left and right pointer, and we'll be comparing those two. And once left is greater than the right, we will need to do different operations. So we try to simulate some things, some scenarios right there, though I am not sure where did we got. So probably would be a nice thing to start again. Not sure if I can. Probably I'll just copy again this part. Yeah, I'll do a screenshot, the elevation map, and let me paste it here. Let's use a new canvas. We'll be putting it right there. Okay, so we start here with the left pointer, we start here with the right pointer. So first iteration, left will be 0, right would be 9, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so it's like 12, but we start from 0, so it will be like 11. So that would be the right pointer. Okay. Now we kind of computed our, let's say, formula. If I recall, we need to check the minimum between left and right, and we need to reduce the height of the current index which we are in. So in our case, if we're playing right here, I, where I would be like, yeah, let me use a different color. So I would be like here. So minimum between left and right will be 0, so we cannot trap anything here. We'll be moving on. I will go here. In this case, we will not be able to trap anything as well, because L in our case will be this one. So this would be like L. And it will be 1, and right will be 1 as well. So if we do min 1 minus height of I, which will be 1, so we have 0. So 0, it's not trapping anything. Okay, yeah. I guess overall the plan is clear, and now we'll need to code it a bit. So let's try to code. I think I've added a couple of scenarios. So our first scenario, and there is another one, so probably we'll add another one. So a good rule of thumb, it's often to set up some boundary checks. But yeah, for now, let's just keep it simple. I'll be just trying to code it. So yeah, what do we need? We will need a left and a right pointer. So let's create them. Let mutable. Okay, so I'll need to move my keyboard a bit on the right because it's a little bit annoying, but microphone sits on top of, or the microphone cable sits on top of my keyboard and it's stuck to code it. Okay, so we have like left pointer, which will be at 0, and we have like right pointer, which will be at height of LAN -1. So this would be like initialization of our pointers. Then we will have like mean left, mean right, mean left, but probably that would be kind of left and right. I don't know. Does it make any sense to have different ones? Unclear. Yeah. Let me put this one here because it looks like that would be the right spot for this. Okay. So we have like we'll need like mean left. Yeah, we'll see. And we'll need like and for now mean left will be like 0, I guess. I don't know. Let mutable but not min, but it will be like max. And max right would be like yeah, we can initialize both of them to -1. It's a good enough number for us to start our computations. What else? We will need to trap our answer. So yeah, I see often like in my country, people learn Pascal, their first language, which is a little bit odd. It's old, but still I think it's a good idea because Pascal teaches you to declare variables usually on top. If I'm not mistaken, you probably can do it later on, but it's a good practice to first declare your variables on top and after write your code and so on. So this practice comes from Pascal. So it's still a good thing for people learning Pascal. That's a good strategy. Okay. So we defined our variables. Now we kind of need to start looping through our content, and we'll have like the default left smaller than right while loop. This one would be like a default for sliding window problems. And we'll be able to return the answer. Yeah, I have some troubles with this cable. I don't know where to put it. Okay, wherever. Let it be. I'll try to manage. So we have our default left and right. If we go here, what's the formula? We need a mean left, mean right, and to compute our h of I. So here, trap, but we kind of need an I to move on. What would be the thing which will be moving on? Left and right, probably. Yeah, this would be the 2 pointers which will be playing around. So max left and max right will be like the references, but everything else would be or the pointers which will be moving would be like one from the right, the other one from the left, and we'll be moving towards the center. So yeah, I guess we'll need to keep track of the max. So first thing we'll do will be like max left would be max left dot max of height of left. So we'll need to update max left and we'll need to update max right. Max right dot max height of right. So we've updated our max left and right because we'll need these two. Next, what we'll need to compute, it's I guess we'll need to compute the water at position at the left index or the water at the right index. Okay, so let's try to compute water at position left. Okay, so let water. So water would be like I32 min between max left, max right, and we'll need to subtract nums or height, in this case height of left. Okay, so compute water trapped at max left. Okay, so we have this part. Yeah, let me add some music. I feel like we missed the music, so box, I forgot how it's called. Sandbox, no. Soundtrack. What's the music, how it's called? Oh, whatever. Okay, so we'll do it later on. Okay, so we have water, and here we have the option because it may be negative. So if this it's less than 0, yeah, that's a little bit not right. So yeah, let's keep just water. So here we'll have like if water is less than 0. Yeah, let's make it mutable because I want to change it. So water will be 0. And we kind of have answer plus equal water. And to not have troubles with this kind of stuff, we'll need to do water dot right dot left. But when do we stop moving on the left and start moving on the right? We will stop. We will stop this. So we kind of will move left till the moment, I guess, where max left would be greater than max right. So we do this while max left is, I guess, less or equal. Can we trap water if it's equal? Yeah, we can. If, for example, height will be 0. Okay, so when it's equal, it's fine. So max right. We do this. And we do like left plus equal 1. So we're moving on the right. Wait, that doesn't make any sense. Because we need this to be inside that loop. Wait. Uh, okay, I guess. Wait a second. This doesn't make a lot of sense. How about this? No, we kind of need them. Yeah, we kind of need this too. So, interesting. Okay, yeah, let's keep it going. Maybe we'll arrive somewhere. Because for now, it's a little bit tricky. So yeah, probably I'll need then to create like some sort of this. I32, um, 0, wherever, and here, kind of need to apply the function. But this left plus 1 will not necessarily work because we'll need to call this part. So maybe a go-to or something, but that's ugly. I feel like we'll need to redo this part. Yeah, this definitely should be rewritten. Okay, yeah, I don't like that. I don't like this. Okay, so we move from left to right. We have the max right and we have the max left. Now I guess we'll start with some if loops. I guess this computation it's good. So yeah, let me copy this because this is useful. So I'll call it just water. But maybe even I can extract it into a function to be a fan. So count water should be fine. So we have like a couple of pointers. We have M left, have M right. What else do we have? We have left. Or I'll call it a pointer. And we'll need to provide the height as well, which will be a reference of back of I32, and what will return back, it's an I32. So let's count this. I'll copy this part, I'll paste it here. This will be like max left. This would be max right. Yeah, so it's not use size, but it will be like I32s. And here it will be like pointer. We don't know exactly which one. So if this water is less than 0, return 0, else water. So yeah, we have a small helper function to count as water. So let's assume I want to count water on the left. Would be like self count water max left, max right, and left. So we have this part, water on the left, and here, yeah, let's do water on the right. So pretty much it will be the same. So maybe I can copy everything here and paste, and then instead of left use right pointer. So we have the left water and the right water. Now we'll need to plus water right. We'll need to increase our answer. Okay, so what's next? What's next? Next, it's we'll need to move with the left and right pointers. Left will need to increment, and right will need to decrement. But the question is, when do we do that? I guess if max left is greater than max right, then we do right minus equal 1. We do right minus equal 1. Else, if else we do left plus equal 1. Okay, yeah. Seems interesting. Is it all? Is it all? I don't really know. Yeah, let's try to run. Okay, it does work. Oh my god. It works just I was not expecting to not have any issues. But it works right away. So looks like and I like the code. I mean, it's pretty simple, straightforward. Yeah, I don't believe that we'll not have any troubles with some tests, though who knows, maybe we are lucky today and we'll have a fast stream and very productive. Yeah, currently trying to run it on late code. So yeah, let's run it here. Working, so let's submit. Maybe it's just good enough. Oh my god, so it is good enough, and we look here. So we have an insanely good solution. Yeah, not expected to be so so efficient. I mean, it's efficient because if we didn't talk much, but let's do an analysis on the solution itself. So let's check what would be the time-space complexity. So for this, I guess we will do, let me temporarily zoom this. So we have our trap. So let's do an analysis of time-space complexity of this stuff. So yeah, let's use a whiteboard. I like to use it here. So here we have space. So space-wise, we have like a big O of 1. So it's constant time. Here we have a while loop left to right. So we move from both direction at the same time. So this would be a linear algorithm. So if we talk about time, it will be like big O of n. Do we have any nested things inside? No, we don't. I guess we use some extra memory, but it's already counted. So memory or space would be like O of 1, constant time, constant space, and time will be like big O of n because we have a while loop. So this is why our algorithm is so efficient. Yeah, we have a couple more variables, but this is not really important. Yeah, if you look here at this function, it doesn't do anything specific, so just some math computation uses inside where it doesn't use much. Yeah, let me zoom in. Yeah, we have an extra variable here for the answer, but it's still constant, constant space. So yeah, Complexity of the algorithm would be time big O of n, where we call it linear, which is pretty efficient stuff. And space, where memory used, it's constant, because we don't use anything extra, and it's not dependent on the input size. So it's extremely efficient, so very efficient algorithm. Awesome. So we finished this problem, and to be honest, I was thinking that this will take way longer than this, but I'm glad we finished it, and we were lucky that the algorithm were I'm not sure how to explain this, but it is at the end of the day a hard problem. And the trick is this sliding window technique. Or if you go here to look deeper, it's this like a left and right pointers. So I guess if you are familiar with this technique, then probably it's not as hard of a problem for you. But yeah, overall, yeah, nice. So we managed to solve this. Let's mark it as done. And I think we are done with 2 pointers. And look here, we have a kind of a interesting color, which means we are done with 2 pointers and we need to move to stacks. Cool. So first problems on stacks would be valid parentheses. I'm not sure, but I think I've solved this one, or maybe not. But this one, it's an, let's say, iconic problem, and I have a story on this one. The idea with valid parentheses, it's like you need to, it's the first problem where we learn how to use stack as a data structure. And we'll see how to solve it, because it's straightforward. Using stacks, it's quite easy. Using other techniques, it's a bit more difficult. Yeah, what's the problem? And then I'll tell the story, what happened with me when I was younger. Because I've received, I used to participate on different Olympiads when I was in school. Let's say I was not like a genius or some sort of geeky math guy, but I was good enough to take some places here and there at in my town where I was learning, and then I used to participate at the country Olympiad. Not good result, but still, I used to participate a couple of times there. So yeah, we have this problem. I had this problem at my school. So usually how Olympiads were done during that time. So in schools, you start by having like a local Olympiad where everyone participates and they elect the best people from the school. So the first places go to the next stage. Next stage would be like a town. So once you pass the town Olympiad, if you got a good result, then you move on to the next stage, which would be like a country stage. And if you are good there, you take good places, then you go even further. So you'll get places on like international Olympiads on informatics. So at the first stage, I mean school level, I received this problem. And at that time, I didn't know, because I was like 9th or 10th grade, maybe. And I didn't know about stacks and how to solve this problem. And if you do not know the trick, this would be a pretty hard problem to figure out. So the funny thing here is how the inputs were validated. So it was not like an automatic things. So the referee would come to your computer and it will dictate you. So you'll be typing the input, And once you hit enter, you'll have like the answer, the result. And this is the first time, and probably the last time when I cheated at an Olympiad, because I didn't know how to solve it, but at the same time, I used the trick as it's a black box. No one was looking at the code. So I just wrote an algorithm to parse the string. If I give a space at the end of the input, so imagine here, I'll have this input, and I'll send a space here. A space is not visible on in console because okay, so we don't need to do this. So let me go back. So if you go to the terminal, for example, I write this. Yeah, I guess that terminal was not visible, but still, it's not totally clear. So, but I was typing pretty fast, and here the trick is, if I put a space in the end, I will treat this as a valid, or a return true, because the thing here is you'll need to return true or false. So yeah, if I didn't press the space at the end, then I'll treat it as false, or something like this. I don't recall exactly how I coded it, but I've just cheated. So I was looking at the input, and visually you can tell that this is a true or false. And if it's true, I just adding another space and hitting enter, and the result would be true. So I have received max points for this problem by cheating, unfortunately. So yeah, and after that, I kind of got better results as I've trained. I learned how to solve this one using a stack. So I've got to the town level, and then I've got like third place or second place. I don't recall exactly now, but for sure it was not like first place. And I moved on to like a Republic Olympiad, or in my country, or country level Olympiad, and was not very good at that time. But yeah, if you practice on lead code daily, I think like you'll be unstoppable at the Olympiads. So that's a good thing. So yeah, that's a funny story with valid parentheses and how I solved it. Because technically, I did solve it. I created an algorithm which was returning true and false. It didn't do anything properly, but oh, Bharat, Bharat Gouda, hello and shout outs. Yeah, welcome here. So hello. Yeah, how are you doing? So I've just finished like solving a hard problem on two pointers technique, and currently moved to solve this kind of problems with stacks. So this is a new data structure. So my idea, I'll be using neetcode.io. So I'm a big fan of the YouTuber and his site and so on. So I'm following his roadmap on learning data structures and algorithms, and I'm trying like to solve all the problems from this list, uh, and learning how to use like all the data structures. So moving slowly towards the end, which will be math and geometry. We go using like a breadth first search algorithm. So we'll do arrays and hashing, then two pointers, then stacks, then binary search, sliding window, linked list, trees, and so on. I already did like a lot of problems on LeetCode. I'm not sure if I can call it a lot. Comparing to other people, I'm like at some sort of beginner level, but definitely more than majority of people, let's say. Um, and I try to do it daily, solve the daily problem. So I have a pretty good streak. I started this year. I started last year, but I had like huge pauses of entire months. I'm a bit more consistent this year. I think I've got like the third badge, yeah, on March. So I've got like 6 badges already. So if you look at all my badges, I'm now working on for the April one. Can I unzoom it or make it? That will not be visible for you though. So I have for February, I have for March, and I think I have one for. Oh, yeah, that would be like. Yeah, I can activate my badges. So I have a badge for January last year, then January this year, February and March. I got like 50 days, 50 days in 2023 and 50 days in 2024. And very likely I'll get pretty soon 100 days, which would be pretty nice. Okay, yeah, so let's solve this problem though. Because I've cheated once, but now I know how to solve it. So yeah, the idea here it's we'll need to use a stack. So probably to explain it better, I'm not sure if I'll need this, but I'll need to use my whiteboard. I know this problem, so I'll not copy any inputs. So let's imagine we have an input like this. So as simplest input possible. How would we deal with this input? It's quite easy and straightforward because this would be a string. So first stage, what we'll need to do is transform it into chars or bytes. I guess bytes will work as well. But important for us, we'll need to know what will be the start of the bracket and end of the bracket, because we'll be creating a stack. So in most languages, a stack is just a vector or an array. Like pretty much all the languages which I'm working with, an array will be good enough to fulfill any stack's needs. So let's imagine we receive this first character. So this start of the bracket. We'll be putting this inside our stack, and we move on. So we go yeah, because the algorithm will be something like this. At first, the stack would be empty. But unfortunately, we kind of need to move on, and we'll go step by step. So we get to the first character. We see if the stack is empty. So is stack is empty. Then we don't do pretty much anything. We will just insert our character in our stack. So first iteration, we will have the start of our brackets. If it's not empty, then we'll need to pick what's on the, let's say, top of the stack. So in Rust, there is a pick, like a function. Another way you can do it's in other languages, you just can check the last element in the vector. So if we move on, so if the stack was empty, we just insert it. So now we go to the second character, but we'll need to check what's on the top of the stack. So if on the top of the stack would be something which closes the brackets, because we'll have like a hash map. Imagine we'll have a hash map, some sort of, if that's the start of, or let's say if this would be the closing character, then we'll need to match the start of the bracket. So that would be the character which will look onto the top of the stack to remove it or to nullify both of them. So we'll do for all the brackets this let's say pairs. What's the start, or actually what's the end, and what would be the start? So we'll need to create a mapping for this. So that would be the end, and this would be the start. So we'll create a mapping like this. So once we have this mapping, it's easy for us because we look what's on the top of the stack here. So we know that on the stack it's this character, but our current character. So let's imagine we have in the stack this, but current character in our case would be this one. Then we check if on top of the stack it's this character, which would be like our pair. Then we'll be topping, or we'll be popping this character from the stack. So on this, so the stack would be empty and nothing would be there. So the stack would be, I guess the stack would be empty in this case, and we'll be processing everything. So how do we understand if this is a valid or not valid thing? It's easy. If we have at the end of, let's say, of execution of our algorithm, if the stack has anything inside, then we'll be returning false. Because this means we did not found all the pairs of brackets and they were not closed properly. If the stack, has something. So let's imagine a couple of charts like this. If the stack is empty, then we'll be returning true. So yeah, let's try to code it. Yeah, it's an easy kind of problem because once you know the trick, it's pretty straightforward, but still in Rust, you'll need to know a couple of things on how to code it to not have a lot of issues. So yeah, I guess we'll be closing this one. And let me create fastly another cargo new lib valid parenthesis 20. So valid parenthesis. Okay, let me zoom it in. Yeah, so I'm just preparing my test cases to code it a bit faster. Struct solution. So yeah, let's add a couple of scenarios. So scenario number 1, let's use this, and this would return a true. But we need to make it to string for this to work properly. So it's valid. So we have one scenario. Yeah, let's create another one, which will be a false. So okay, I guess we'll need this, and we'll need to remove this. So a false scenario can be like this. So this one would be a false. Yeah, I'll need to add a couple more. Yeah, let's add a couple more. What do we have here? This one seems good. To string, and this will return true. So I hope, yeah, it's auto-aligned perfectly. Nice. Okay, so yeah. First stage, as I've told, we'll need to create a stack. So it will be an empty vector. Next stage, we'll need to parse element by element. And in our case, it will be a for loop. I'll call it maybe bracket. And we do s.chars. So we'll have our brackets. And now we'll need to write our code, but we'll need to have like this mapping, which I was talking about. But yeah, let's see, match. So let's assume, I guess let's go first if stack is empty. we'll be writing this code. We do stack.push bracket. So we are pushing the bracket here. So I guess we can do it like if stack is empty, we'll be returning false or true. Yeah, because we nullified everything. And if not, we'll do false. So kind of that would be the, let's say, the skeleton of our algorithm. So if the stack is empty, we'll pushing the item. If not, then we'll need to do else. We will need to do some matching. Okay, so let top of stack. We can do like stack.peak. Is not so stack vector. I guess probably can do pop. We know that we have something, so probably we can do unwrap as well. So that's not an issue. So probably we can get it, and then if it's not, let's say, matching, then we'll insert it back, including the other bracket. But the trick, though, it's a little bit more interesting. So yeah, let's try to code it first. So we have like top of the stack. So now we do match, and we do like a bracket. So if bracket it's this, let's say, what did we do? So if bracket is this, I guess I can just use this mapping which I provided here. That can work. Yeah, that definitely can work. So we have bracket. If this is the bracket, we need to check if top of the stack is this start, I guess. But probably I'm just okay. So if it's this and this, then we do. Guess we don't do anything. We just if it's not this, okay. So yeah, because we popped it. So if we pop it, we don't care. So if the top of the stack it's not equal to, I mean, this pair of brackets, what should we do in this case? We should add it back. So stack would be push top of the stack. Yeah, that's a little bit tricky, but and we'll push bracket as well. So we'll be pushing this too. Yeah, what else? I guess we'll need to do a similar thing for the other ones. We'll need to do similar things for this stuff. And probably this code is repeating a bit. Yeah, I don't think it's no, it's not repeating it. So we have like different so maybe we can optimize it, but we'll try to reduce the code. We'll add some parameters. So we have this one, and the top of the stack needs to be this one. And it will not allow us to move on because we'll need to have like a default value. So we have this. if everything looks good, then we should be fine. Okay, so it doesn't work. Oh, not everything is working, so that's another thing. So this doesn't work as we forgot to add this stuff. So now it's working. So it does work. And it's a bit more code than I was expecting, to be honest. I mean, yeah, we managed to solve it, and I'm pretty sure everything works just fine. But I would like to optimize and make it a little bit smaller, because we have some repeating code first, and it's a little bit annoying though. So yeah, let's check. This works, and if we submit it, oh, so we have a scenario where it doesn't work, which is interesting. So yeah, let's try to debug that scenario, or this scenario. I'll put it first. So we expect definitely for this to be true, but it's not. So let's check it. Yeah, let me debug it. So yeah, port, I don't need it. So I probably can move this on the right side. Okay, so we have the brackets, stack is empty, we push first bracket. So we have starting. We have the next one. Oh, I kind of understood my thing here. Because the trick is we will need to move a bit recursively and pop things from our stack, because this is not right. So yeah, if you, oh wait a second, looks like I have a bug or something. No, something is not right. Let me restart. So let me comment everything just to be sure that this is working just fine. Okay, we pushed first, else we pop. Wait a second. If it's nothing like this, yeah, that's the case. So yeah, this is a little bit very annoying, to be honest. And now it did work. So yeah, that's tricky. Okay, so yeah, the case was we didn't found any matching here, and we, in this case, we just push the thing which we had on top of the stack. We push it again on the stack, and we push the bracket. So as you can see here, we repeat the same code like 4 times. And I'm thinking, is there a way on how we can optimize this? So let's ask Clippy. Okay, so help. Yeah, actually, that's a good point. We don't need to check. So we can do it just like this. So cool thing with the unit tests is you refactor your code, and then you can run fastly and see if everything still works as expected. So that's a good thing to have when working with the unit tests. Okay, question: how can we optimize this? So yeah, let's get back to Clippy. Yeah, Clippy doesn't tell us much. Okay, yeah, we solved the problem. Now I can show you a trick on how Copilot can be useful. So I use it at work and kind of liked it. So I can tell things like Copilot, please refactor is valid function to use less lines. So Copilot will think a bit. Okay, so it suggests me to create a hash map and to oh my god, that's way better than what I'm expected. Yeah. So I guess we can use this approach and see how it will it's less code and uses like a hash map. So yeah, let's try to import this hash map. What I don't necessarily like, it's cloned. Why do we need that? Okay, because we don't want to have like references. But do I care about that? I don't know. I mean, yeah, let's try to just collect. No charts. Okay, so let's be char here and char, whatever. So yeah, we'll need to clone this. Oh, because it's not vec. Okay, so what's the trouble? Because yeah, this would be like char of chars. Okay, whatever, let it be cloned. I mean, I don't necessarily think that that's a huge deal. We will just be creating a clone of this and inserting the hash map, but at least we'll have chars and chars. So what's the algorithm doing? So we check the bracket pair. So for the current bracket, we check its pair. So it's exactly what I've stored. So exactly this. So that's the hash map. So kind of I was brainstorming it the right way on the whiteboard. So we have the pairs as tuples, and then we create a hash map out of this. That's cool that I don't need to create like a vector, because this will be a dynamically typed. So here the trick is we'll be doing like a brackets get. If we have something, expected open bracket, then we check if what's on top of the stack, as it's possible. Okay, that's a little bit different way, but I guess the trick is we look what's on top of the stack. If it's not closing or expected open bracket, then we return with the false right away. So we will not looking even further. In the other cases, we will push the bracket inside our stack. So yeah, this is definitely shorter, but not necessarily one that I would write, because this is a bit too smart for my taste. So yeah, let's get back to our code, because this we know better, but refactor it in such a manner that I would be kind of the owner of things. So yeah, Copilot is smart, everyone knows. For things like this, like trivia problems from lead code, it's trained very well. I mean, can solve anything extremely fast. So yeah, first thing which was in my plans as well, we'll need to use collection. So let's use a hash map. So let's do like pairs or bracket pairs. Yeah, let's call it bracket pairs to read better. I guess, yeah, let's stick with the same approach. So we'll have like the tuples. So we have open, close. So first tuple, a second, third. So let's use square brackets. And last one would be like block brackets. So we have, we'll need to create an iterator, then we'll need to clone it, and then we'll need to collect a hash map. And we'll need to provide like, but I guess it will know because we told it here. No, we didn't tell, so we'll need to tell it here. So hash map of char of char. So we have our bracket pass, so that would be useful. So here, instead of checking if it's empty or not, instead of checking if it's empty or not, how can we leverage this bracket pair? Okay, let it be for now. We push it. Else, and we do, yeah, let's try, let's remove this for now, or command this part. So we have like top of the stack. Yeah, the other way around is to write something like this. Let's top stack bracket or stack bracket equal to stack dot pop. So to not do unwrap, because you should try to avoid at pretty much all costs unwrapping in your code. So yeah, we check what's the thing on top of the stack. So here we'll need to check as well if let's expected bracket being equal to bracket pair dot get, and we do current bracket. So expected bracket would be this. If stack bracket is not equal to current bracket or to expected bracket, yeah, and we kind of need to dereference one or reference the other. So I will dereference this one. If they are not equal, then I guess I'll just push them back. So stack that push, stack bracket, and stack that push bracket. So we push everything there. So it's a little bit less code, written differently than mine, and all tests are working fine. So that would be another way on how to write it. Probably I like this a bit more. than what AI suggested. So I will stick with this one. Yeah, still pretty good code. So we have yeah, I don't know, a kind of maybe I would use a match here somewhere. Yeah, I don't know if we do need this, because maybe I can just remove this if else stuff. That would be the thing here. So this is also working just fine. Because we're already doing this thing. We get top of the stack bracket from pop. If there is nothing on the stack, it will be like none, and it will get into this else loop. So that's even shorter. So we trimmed a bit more. Yeah, let's check what Clippy has to tell us. Maybe there is something more to trim. Yeah, about valid dead code. No, that's I guess that's it. So let's submit this output. That would be my solution for it. So yeah, let's submit this and hope everything gets. Oh, this is pretty cool. How this one gets to be. Yeah, this scenario I didn't test. So yeah, let's check this. Yeah, let's add it. String. Yeah, this probably it's a false scenario. So what's the trouble? We insert once, so stack pop, nothing. But here expected bracket. So how did we get to this stage? Because I don't really understand this. Yeah, let's debug it. Okay, yeah, let's move this on the bottom. Here, I guess we have stack and it's empty. We push first item on our stack. Okay, we move on. The second open bracket. On top of the stack, it's stack bracket is this. Expected bracket. What's the expected bracket? Oh, so there is none. Okay. Yeah, I know we forgot this. Uh, hmm. Yeah, it's a bit repetitive. We repeat it too much because we'll need to push it here because if there is nothing on our stack or it's something which is not expected from us. Second example doesn't work. This one. Wait a second. Okay. looks like I missed to do something here. Let me check. Let me check this. Yeah, let's debug it. So we got here, we push. We got here. It's not there, we push both. We've got here, we pop. So we have an open. Then we've got here stack bracket and bracket expect. Yeah, I think I have a bug in my code here. So this should be in this direction and this should be in this direction. So that's the trouble. Okay, so we found the bug. And all scenarios are good. Though I still don't like what I'm seeing. Because, for example, this part, fortunately, we cannot do much with let sum. Maybe we can join these two into one. So maybe there is a way to join them. How can we refactor this to get rid of them? The other way around would be to pick or to check what would be in the last. So how we can do this? Instead of popping it, we can just check if it matches, then we pop. That's the other way around. So I guess it's lost. I think it's lost. So stack.lost. Do we need to unwrap? I think we'll need it. It's an option, yeah. Because it may be empty. So in the case where it's empty, it's a bit trickier in this case. So we'll need to kind of unwrap it. But we'll need to be sure that it's not empty, so it's still not trivial. Okay. Yeah, kind of what AI suggested. It's by far the best way. So it checks for bracket pair. Then it looks expected. Okay, so if it's none, then we push. Yeah, this is way better. So if we go here, it would be something like we'll be matching stack dot not stack but pairs bracket pairs dot get bracket. We'll have two options. We can fill the matching arms. So closing bracket. So here in the case where we don't have anything, it's quite straightforward. We do like stack that push bracket. But here we'll do f let's sum. Yeah, here the trick, because if I still want to kind of feel like I need to compare and put, but they didn't do they don't do this. So if what's the trick here? If stack.pop is not equal to sum expected open bracket. Oh, okay. So I don't know about this structure. Stack.pop not equal to sum closing bracket. We return false. So let's check here. So we do stack.pop. If it's anything different than the closing bracket, then we'll tell that wait a second. So we have for this case. So if they're open, we can add how many we want, because this would be pushed. But if it's closing, it needs to be closing when the stack is good. In all the other cases, it will be just return false. Okay, so that makes sense. Yeah, it's way smarter than what I was planning, because kind of I tend to write the if-else statements to compare, but they go the other way. I mean, instead of comparing like all possibilities, they go backwards because it's easier in this case. It's a good like strategy or pattern to check the problem in reverse order. So yeah, even knowing the stack that this problem is solved pretty fast using a stack. If you don't know this, I assure you, you'll spend some time, a lot of time trying to figure it out. So yeah, I've spent some time like trying to figure out ways and how we can optimize this. But yeah, let's check if this works. So we did some refactoring. Yeah, it works. Let's run it again on late code and see if this is accepted, because maybe we have another bug or something. Okay, so I have it defined multiple times, which is easy fixable. And let's submit this. And kind of we solved it. Unfortunately, it looks like only us solved it. So yeah, I would like to check a bit acceptance rate. Look here. So even this is an easy problem. It has a pretty rough acceptance rate, so only 30% of people. So usually like easy problems with 60, 40, 60, 70, 80%, there are literally easy problems. But this is stack of characters, okay? And when you encounter an opening bracket, push it on the top of the stack. When you encounter a closing bracket, check if the top of the stack was opening, you pop from the stack, otherwise return false. So yeah, if you don't know the trick, this problem is tough, literally. But see, it's a useful problem to know. It's an idiomatic one. Okay. Yeah, we are done with this one. Let's, I guess, mark it as done. And let's move to the next one. The min stack. I don't know what this is about. So this one looks like we need to implement something. Okay, so cool. So we'll need to implement a stack that supports the following things like push, pop, top, and retrieving the minimum element in the but the trick here it's retrieving the minimum element in constant time. I kind of hmm. I mean da, da, da. I guess what we can do is for the stack itself, I'll be using like okay, so let's have like a data thing. For this, I'll be using a vec. Uh, so kind of yeah, we'll need to do it like this, I guess. Vec of I32 because everywhere is defined already the type. But we'll be keeping as well a mean value like mean val, which will be on I32. So we'll need to make sure every time we mutate our data, that mean val it's adjusted. Because the trick here, it tells you must implement a solution with O of 1 time complexity for each function. Wait a minute. Okay, push would be of 1. Pop would be of 1. Uh, top. But what was the difference between top and pop? Gets the top of element on the stack. Okay, so yeah, getting the top element, it's fine. Retrieves the minimum element in the stack. That's a little bit trickier though, because if we are doing an operation with the min stack, get min, no, I mean maybe this works, but I don't think I can implement it in O1 though. Because imagine we have the following scenario. So yeah, let's assume we start a new thing. So we'll do like a self. Here we'll have like a min val. I can start with I32 min probably, or max. Yeah, probably I32 max, and then I'll use a different thing. But here for back, I can use this. So we'll be defining our self for now. So when we push on stack, we just do, here we'll need to do a mute, and we'll do like self that push val, self that data, push val. When we do pop, we do like self that data that pop. But here we'll need to do as well some checks, like if but actually not this, but we'll need to do like self dot min val would be self dot min val min val. Yeah, it's a bit cryptic, but overall it's fine. Okay, so I'll need like a technical pause of two, 2 to 3 minutes. I'll be back. I'll be back in a minute. Okay, so got back. So for popping things, yeah, for popping things, we'll need to do some checks. If let some val will do equal self that data that pop. Yeah, probably pop here with yeah, that's a little bit interesting because on their definition they do not show it here to return the value, so you just pop and you don't care. But in our case, we do. Here is the trick, because imagine we pop, but in this case, we'll need to check. We'll need to update our min value, and we do not know what's the next one in the list. So what data structure we can try to use for this? Maybe it's a min heap, but in this case we will not have a stack. Yeah, that's interesting. That's definitely an interesting one. Yeah, let's see. Consider each node in stack having a minimum value. Consider each node in the stack having a minimum value. Okay. Yeah, I'm thinking maybe we should wrap up and continue with this problem next time. Next time would be like on Tuesday. So yeah, Tuesday would be a good day to continue this one. I also will be thinking a bit on how we can how can we optimize this and make it big of one. Because the trouble is, I mean, I can write it and probably it will be accepted even. But here I will need to traverse again my stack, and this will not be big of one, but will be big of n. Because if I have a lot of items in my data, here I'll need to find a new min and do something like self. But wait a second. Maybe we can even optimize this. We can do if vol is equal to self.mean_val. In this case, we'll need to do this operation like this min_val will be equal self.data dot iter dot min as I32. We'll need to provide a new min. So this part is not big O of M1. So yeah, if we extract the minimum, it happens that on top of the stack it's the minimum value. Then we'll need to find the next minimum. And for this, we'll need to traverse again the vector and find it. But that's a bit weird. I don't see any difference between pop and top. Maybe top will show, but will not get. And for this, I will just do self.data .self.data.len -1. So this would be the top of the stack or the last item. And min will be like self.mean_val. So in theory, this should maybe work. This, okay, so it looks like I wrote some JavaScript there. Okay, so help remove this generic. Okay, I will remove it. Yeah, can it do like oh, maybe I'll need to dereference it. Yeah, probably need to dereference. Okay, let me dereference that. Okay. Oh. Oh. Oh, whoa, 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 whoa. Okay. I mean, yeah. Let's do like this. If sum, let's sum min will be equal to self.data.iter.min. Then in this case, we'll do min val equal min. Found I32. So this needs to be dereferenced. Okay, so let's dereference it. Okay, so cannot borrow self data as mutable as is behind a shared reference or a reference. But how am I mutating it? Because I don't get it. Yeah, this needs to be mutable self. Okay, so yeah, this kind of works. And if I submit, what? Min stack push top. Push top pop. Get min pop push top get min push. Expected. So what's the difference? So it's expected this. And this is get min, I guess. Yeah, looks like I'll need some time to figure this out. Very likely there is some bug here and there where I'll need to find it. And let's check. And I'll likely it's somewhere here. Okay, but I guess this will be done next time. So thank you everyone for joining in. Yeah, it was a pretty productive session. We managed to solve like 2 problems, which is good. Yeah. Have a nice evening. Bye bye.